So there's a lot of buzz and speculation, rightly so, directed at what's happening with GenAI and where's it going. And one of the big concerns that we hear about is AI is going to take all of our jobs. So I've tried this. And when I try to get AI to take my job, the result looks something more like this. And then I probably agree with a lot of this statement from Elon Musk that AI will surpass human intelligence eventually in most tasks, and eventually generative AI will do everything, almost everything better than we can. So maybe, maybe not. Let's look at the results today. Here's an example of this poor NBA player who had the worst night in his career not too long ago, where he had 0 out of 10 field goals for his last game. And this was reported in SFGate, which is a San Francisco-based media outlet, as shooting bricks. And shooting bricks, if you're not familiar with that term, it's like you miss the basket and the ball drops like a brick. And to add insult to injury, here's what happened with Grok, is it saw the term shooting bricks, and it confabulated this whole story around how Klay Thompson had been accused of vandalizing multiple houses, how the authorities had been called, and this basically took this guy's just disastrously bad day and just made it 100 times worse. And then another issue, another quote is from Sundar Pichai: AI is more profound than fire or electricity. Generative AI has the potential to reshape industries, creativity, problem solving, and it's just the beginning. A lot of this is probably right, but again, like well-intended companies trying to use this technology now end up getting into a lot of trouble in spite of their best intentions and best efforts, such as probably you've all heard about Air Canada's chatbot offered a discount that wasn't authorized under the policy, and the person contested, they ended up in court, and then the consumer won. So what's going on? We've got, it seemed like we had this hockey stick moment with GenAI, right? It was almost exactly 2 years ago. ChatGPT came out. You've got this parabolic curve. But then, pretty quickly, at least those of us in the enterprise trying to apply this technology to do things, ended up hitting up against this barrier. So what is this barrier? Well, early on, maybe a year after ChatGPT, this meme was floating around. A lot of you have probably seen this. It's what's the difference between a parrot and ChatGPT? Learns random sentences from random people, talks like a person doesn't understand what it's really saying, occasionally speaks absolute nonsense, and is not a cute little bird. But what this points to is a gap between the way we'd like to use this technology and what we can actually succeed in using it for once we've actually got hold of it. Now, things from the consumer side have definitely gotten way better. I'm super impressed at LLMs. But from the enterprise perspective, what are concretely the things that represent this gap? It's lack of enterprise domain knowledge, ethical and bias concerns, access to the most recent data, inability to verify answers, and then privacy and security challenges. So I'm going to propose that the way past this has to do with your data. It's what data you use, but also what format it's in and how you use it. And all of you have probably used RAG with vectors at some point, and this clearly raises the bar. You can do more with RAG with vectors than just an LLM, even with fine-tuning. So, but in spite of that, you see these pretty amazing predictions of like massive amounts of revenue generated over the next decade by companies doing GenAI. But in 2024, the reality is 70% of enterprise projects or more are stuck in a pilot phase. You can easily get to a really impressive pilot, or it takes some work. But getting beyond that into production, oftentimes there's a higher bar. So why is this? Well, one way to look at this question is looking at your use cases and looking at what's at stake. So what's at stake if you have a right answer, and what's at stake if you have a wrong answer? If you have a right answer, oftentimes the value is very, very high. But for use cases where the value is very, very high, oftentimes if things go wrong, the risk and cost is very, very high. So there's some relationship between value and risk for higher stakes use cases. Let's map it back against LLM use cases where that are below the bar, where an LLM will do a great job. And it tends to be things that are business peripheral, where creativity is maybe a feature, not a bug, or it's at least acceptable. And then you go to RAG with vectors, and you can actually get into some core business use cases, but invariably you need a human in the loop. So this is great. AI is an assistant. I'm a big fan of that. I use it that way myself. What's left above the line is higher stakes use cases that belong to the core business, but where there's high impact of a bad answer. High dollar value, shareholder impact, brand and reputational impact, health and human safety, bias, all these things that we don't accept. So how do we raise the bar? And I'm going to actually point to maybe something that's unexpected as a way to point the way for where things are going in the GenAI world is web search. Web search started out with all these companies going and indexing a bunch of text. They had no knowledge of what that text is, the indexes, that is. And that got you to a certain point. And then Google disrupted itself by actually creating a graph of the structure of the pages in which that text existed, and then running a graph algorithm that they invented called PageRank to actually get to the next level. So they disrupted everyone. But then they disrupted themselves in 2012 with the knowledge graph. So what's the knowledge graph? This blog post from 2012 nails it pretty well just in the headline. Things, not strings. And this is where we are in the GenAI world, right? Is we've got technologies that are dealing with text, dealing with strings, that don't actually understand what those things are. But if you complement it with knowledge that is a reflection of your world model for whatever part of the world your system is responsible for, then you can actually get to the next level. So what is a knowledge graph? Maybe an easy way to think about it is, let's look at a simple object like an apple. So the human view of an apple is something like this. Obviously, it's much richer. It's three-dimensional. It's got taste and crisp and texture. The vector view of an apple looks like this. There's actually not anything you can do with a vector by itself. Now, if you have a vector and another vector, that's useful. I can compare a distance, still can't do anything with it. But then if I have a third vector, then I can compare the distances and get semantic similarity. And that is genuinely useful. But I don't really know what's happening, and it's effectively one algorithm. It's a black box. And the knowledge graph view of an apple looks like this. It's declarative. Humans can understand it. Machines can operate on it. It comes from a tree. It has a body with certain aspects and so on. And graphs show up in a lot of places. In fact, any place where you have data that shows up as a network or as a hierarchy, these are forms of graphs. And oftentimes you have multiple hierarchies that combine together, which becomes a more rich and complex kinds of graphs. So you see this with commerce transactions. You see this with products and parts, bill of materials. You see it with customer relationship, customer 360. You also see it with digital twins. You could maybe argue that a digital twin is merely a representation in a graph of whatever real world or digital world system exists, which is a pretty expansive definition. Under that definition, any real world system stored in a graph is a digital twin. And once the data is in the graph, it can help answer some pretty big questions. What's important? What's unusual? What's next? It turns out that you can predict someone's behavior better if you know not only how the people they interact with, but people that they've never met that interact with the people that they know. That's a better predictor than having all the facts in the world about a single person. And this applies not just to people, but to computer networks and biological networks and payment networks. So once you have your data in a graph, next step is graph RAG, which actually many companies are finding. I've spoken with dozens, if not hundreds, that GraphRag is the next unlock, is bringing this declarative knowledge for higher stakes use cases. Now, GraphRag is simply retrieval augmented generation, where the retrieval path includes a knowledge graph. Here's an example from the Google I/O keynote. They launched a new product and capability saying, and here's the, my family and I are going to Miami for Labor Day. My son loves art. My husband really wants fresh seafood. Can you pull my flight and hotel information from Gmail and help me plan the weekend? That's a pretty complex question. It's definitely not just a search. And the way they describe solving for it is pulling together from the knowledge graph a graph representing all the things that related to the subject and object in the question, information around it, feeding that to the LLM and getting a better answer back. Another place where you see knowledge graphs show up is in NVIDIA's GTC keynote. You can see three kinds of data sources on the left: vectors, structured data, ERP, CRM, and knowledge graphs. I give Microsoft credit for not inventing GraphRag, but making it popular and giving it a name. So we were thrilled to do this and have actually contributed to their repo and working closely. But they wrote a paper showing GraphRag demonstrates substantial improvement in the quality of results compared to vector-based RAG. And then if you look at pundits, analysts such as Gartner, they're predicting that by 2025, which is just a few months off, I guess maybe end of year, 50% of GenAI initiatives will improve reliability, transparency by combining deep learning foundation models, i.e. LLMs, with knowledge graphs. And they even have like this impact radar for GenAI, where there are two things at the center. One is GenAI-enabled virtual assistants, and the other is knowledge graphs. How does GraphRag work? Pretty simple. You have your application, you ask a question, send that question to an embedding generator, so it gives me a vector. But then you can also do a vector query, do a knowledge graph query, send it back to the LLM, and get a better answer. What does GraphRag get you? Gets you better accuracy, easier development, gives you explainability and governance. And I'll talk about what these are. From a higher accuracy perspective, what's actually interesting is it's not just about whether an answer is accurate, it's how useful is that answer. So let's take an example. We have a repo out there that you can find that's linked to in via one of the pieces I'll have a QR code for later, which looks at ingests SEC data, Security and Exchange Commission, from a data set called Edgar, vectorizes it, and then here's the answer you get to the question with vector-based RAG: which asset managers are vulnerable to a lithium shortage? And it's things like companies that make batteries, companies that have batteries in their products. That's accurate. If you add GraphRag, you get a list of 10 companies back. Now imagine you're a hedge fund manager and you're trying to rebalance your portfolio. There could be $1 billion difference in answer A and answer B, because this might take another day of research to get to the bottom of. Both accurate, one much more useful and powerful than the other. The first GraphRag benchmark to appear was in late 2023. The term GraphRag wasn't yet used, but by data.world, showing a 3x improvement in the accuracy of LM responses with a knowledge graph. LinkedIn published this piece, which shows that GraphRag improved their medium per issue resolution time from customer support by 28.6% for their customer service team. And I see more examples every day. Number two is easier development. So let's go back to this picture. Just think about you're developing and the difference between seeing the thing on the left and the thing on the right. Like the left one on the left is clearly easier to understand and debug because it deals with concepts and meaning. It supports explainability and human understanding, supports human but also machine reasoning, relates concepts, also reveals emergent statistics. You can do kinds of unsupervised learning such as centrality and clustering, and this is what PageRank was back in the day for Google. And the answers are deterministic. Some questions, it turns out, have an exact answer. So why not use a technology that can, and an approach that can give you an exact answer rather than depending on this stochastic approach. So one is transparent and explainable, the other is opaque and implicit. And the observation from many AI engineers that take this approach is you can already fix some bugs on the vector side by actually having the graph side paired up with it. And this is not dissimilar from the human brain. You've got a right hemisphere, which is unpredictable and spontaneous and creative, but I don't really know what it's mostly right, it's sometimes really, really wrong, and I have no idea why. Then you have this left side, which is more discerning. You can, reason. So these two go hand in hand, and I would put forward that for the GenAI problems that require both hemispheres, you can use GraphRag and a knowledge graph to supply the left hemisphere, giving you knowledge, facts, context to complement language, statistics, and creativity. And last but not least, explainability and governance. So here's an example of how you can actually apply fine-grained access controls to the knowledge graph as a way to effectively coerce the model into not even knowing about the things that it shouldn't know about. So important for security, privacy, and then explainability is kind of self-evident. You can understand what's going on by looking at the graph. So coming back to our step one, it's using the right data in the right form. And that in the right form means you need to create your knowledge graph. So where does it come from? If it comes from, it can come from structured data sets. Turns out, you probably have your product hierarchy or your customer data or so on in relational databases. So that's actually pretty easy to bring into the graph. There's an ISO standard around it. Actually, this year, ISO GQL came out as a new language, as a sibling language to SQL. First time in 37 years, there's a new ISO standard database query language. Can come from purely unstructured data, or if I have just unstructured data, it's actually a lot easier if I also have some structured data to go with it to help with the entity extraction. Structured data, easy, solve problem. Mixed, a lot easier. Unstructured, watch this space. But I'd like to give you an example. I didn't trust myself with the demo gods, so I'm going to give you a screenshot of something I did yesterday based on the first night. Who's here for the first night? I took this video, opening night, and then I actually dropped it into this tool, which is free, open source. There's a hosted version you can use, and I'll give you a QR code. You can check it out, where I just basically dropped in that video. It digested it into a graph, 869 nodes, 686 relationships, and generated a graph. So let's zoom in a little bit. Hopefully some of you can see this. I zoomed into what I thought was actually one of the really cool talks, which is CO2 Made from this company 12. And here you can see, they talked about the plant in Moses Lake, Washington, and you can see their partnership with Mercedes-Benz, and so on and so forth. And then here's another part of the zoom in where you can see the company. Now this actually came off of Google transcriptions, YouTube transcriptions, so 12 was the number, and they spell it out 12. And then they misspelled Itasha's name. She spells with it an E. But anyway, you can see how this doesn't have to be so hard. This actually takes you pretty far in getting a first step, even if you don't have structured data. So here's where you can try it yourself. Feel free to give it a shot. And I'm going to close with a few other learning resources and follow-ups. So to summarize, get the right data, convert it. Now, the LLM Knowledge Graph Builder, which is the demo I just showed you, it's good for learning and playing around. If you're actually building a pipeline, you would want to use, Neo4j has a Python library you can use that will actually help you with entity extraction. Llama Index, LangChain, Haystack all have frameworks for this. But by using it, then you can no longer have brick vandalism sprees that didn't happen. You can no longer feel like you're putting yourself at risk as a company trying to do the right thing and use new technology. And Learning references, there's a great course on deeplearning.ai called Knowledge Graphs for RAG. Takes about an hour, maybe an hour and a half to finish. You can find that out there. There's this free book called Building Knowledge Graphs, which goes much deeper into how to build them. I wrote a piece called the GraphRag Manifesto, which makes an argument for all the things that I just talked through. And the best thing about this post is not just not the post itself. There are a lot of links at the end with more learning and exercises and open source links and so on. And then, last but not least, Neo4j's had a Graph Academy out there for many years for you to just get up to speed on graph topics. So feel free to use that. So I'll close with that, and thank you very much. Hope you learned something, and hope some of these takeaways are useful.